Hi, this film talks about the importance of oil in the lubrication of turbine. Turbine is a mechanical device that converts energy of the working fluid into rotational energy. This rotational energy is mostly used to convert to electrical energy in a generator. There are different types of turbines depending upon the working fluid. If the working fluid is water, then the turbine is called a hydro turbine. In a hydro turbine, the potential energy of water stored at a height in a dam is used to convert to kinetic energy in a turbine located at a lower height. The kinetic energy of water is converted into rotational energy of the turbine. If the working fluid is steam, it is called a steam turbine. The boiler heats the water to generate steam. The kinetic energy and pressure of steam is then used to rotate the steam turbine. Thus, the energy of steam is converted to rotational energy of the turbine. The rotational energy of turbine may be further used to rotate electrical generator to convert into electricity or to drive equipments like gears in industry or propeller in case of ships. If the working fluid is flue gas, then it is called a gas turbine. In the steam turbine, the oil separates the moving shaft and the stationary bearings. Before the start of the turbine, the pressure is developed to keep the shaft floating. Once the shaft starts rotating, the pressure is developed by hydrodynamic principle. Jacking oil pump supplies high pressure oil to the jack up the turbine generator shaft to prevent boundary lubrication, and may also supply high pressure oil to drive the hydraulic motor for the turning gear, also known as the barring gear. During startup and shutdown, auxiliary oil pump supplies the control oil. Once the turbine speed is more than 2850 rpm, the main oil pump takes over. When the speed is attained, the wedge of oil created in the clearance between the shaft and the bearing builds up pressure which keeps the shaft floating. This condition of lubrication is called hydrodynamic lubrication. The lubricating oil passes through oil cooler before it can be supplied to the bearing. Under emergency, that is, in the case of power plant AC supply failure, lube oil can be supplied by a DC oil pump before the turbine is turned or barred. The turbine oil is also used to lubricate the bearings of the generator, which also seals the hydrogen gas which is used for cooling the generator. The turbine oil also carries away some of the heat generated at the bearings. Among the turbines, the highest operation temperature is seen in the gas turbines, where hot spots can cross 285 degrees Celsius. Same holds true for modern ultra-critical steam turbines. Hence, the life of oil in gas turbines is restricted as compared to steam and hydro turbines. There is also the risk of contamination with steam and water in steam turbines and water turbines. The turbine oil requirements are built around these operating conditions. As can be seen, the higher RPM is seen in gas turbines, as also is higher temperatures. In the case of hydro turbines, there exists a risk of contamination with water, and in steam turbine, the risk is of contamination with steam. To ensure hydrodynamic lubrication, gas turbines need a lower viscosity oil as compared to a hydro turbine. This is because of the lower speed of the hydro turbine. There exists a need to have anti-rust additives to protect turbine systems from rust in case of water and steam ingression in hydro turbines and steam turbines. The hydro turbine and steam turbine should also have ability to separate water and steam to ensure trouble-free operation. The turbine oil should also release air quickly and not cause foaming to ensure smooth operation. Adequate amount of antioxidants should be present in the oil to resist oxidation in steam and gas turbines. At the same time, the base oils should have good solubility with the additives used so as to ensure good filterability of the oil. Turbines having gearbox need anti-wear and extreme pressure additives which protect the gear, at the same time taking care not to corrode the yellow metals like copper, brass and bronze. Finally, variety of additives like metal detector, corrosion inhibitor, antioxidants, anti-foam, demulsifier and in some case anti-wear additives are added to the mineral base oil to formulate a turbine oil capable of dealing with the smooth running of the turbine. The design of the bearings and the selection of oil viscosity coupled with the shaft speed go hand in hand with the necessity of hydrodynamic lubrication. The ability to separate water and prevent rust necessitate the importance of anti-rust additives and inbuilt ability to separate water. The ability to resist hot spot temperatures and give long life demands that hydro-finished base stocks are used which respond to antioxidants. The step-down gearing needs protection from anti-wear and extreme pressure additives which protect but at the same time prevent attack on yellow metals. The turbine oils are made from deep hydro-finished base oils and select additives. These base oils are made at HPCL Mumbai Lube Refinery, the largest base oil refinery in India. The crude oil comes from the Middle East, which is heated and undergoes fractional distillation under atmospheric conditions. The atmospheric tower bottom, called the reduced crude oil, is then charged into the vacuum tower under vacuum conditions. The distillates are tapped off. The distillates undergo solvent extraction where NMP is used as a solvent. The aromatics are extracted and the raffinates are further subjected to deep hydrotreatment and catalytic dewaxing known as MSDW. The distillates are then fractionated and treated for removal of sour gases. These base oils are then transferred to Musgao blending plant where they are blended to get the required viscometrics and additives are added to get the required performance characteristics. The performance characteristics are standards like Bureau of Indian Standards, German standards like DIN DIN, OEM standards like BHEL, Siemens, Alstom, General Electric, GE. Turbinol XT grades are used in turbines featuring a gearbox. Here, select anti-wear and extreme pressure additives are added to protect the gears. Not all turbinol grades find use in turbine all the time. Turbinol 77 is used in suspension bearings of diesel locomotives. The suspension bearing is a journal bearing which separates the motor support and the rotating railway locomotive axle. The cleanliness of oil is another important aspect. Turbinol grades are filtered to fine levels before filling in containers. The most common cleanliness standards are the NAS 1638 and ISO 4406 standards. These standards measure the particle size and the count in 100 ml of oil. This is measured using a laser counter monitor. Turbinol grades meet IS 1012, Siemens TLV 9013-04-01, Alstom HTGD 90117, GE K 107395, GEK 101941A, GEK 32568F, GEK 28143A, Russian specification TU 38.101821 2001, LMZ OJSC, approved by All Russian Thermotechnical Institute, meets Chinese standard LTSA GB 11120 and ISO 8068, LTSA, LTGB, LTGSB, LTAC, LTGB, LTGF, LTGAC, BHL Haridwar, specification ST 22001. Turbinol XT grades is specifically recommended for lubrication of gear turbines.